Okay, here we have the quadratic formula. We're going to use it to find the roots. Remember, roots are also x-intercepts of a quadratic equation. So degree 2 polynomials is what this works for. The equation has to be in standard form, which means it has to be ax squared plus bx plus c. And the b squared minus 4ac, this part inside the square root, is going to be called the discriminant. It's going to tell us how many real number roots we have. In the equation, you'll notice that there is a negative out in front of the b. That negative should be read as the opposite. So if b equaled 2, that would mean the opposite of 2 would go in the front of that equation. And if b equaled -3, I would put the opposite of -3 or a +3 in the front of that equation. The other item that I want to point out is this plus minus in the middle. That means that we actually have two answers sitting there. One has a plus, one has a minus. We just chose to write them together as one. For our first example, we're going to identify the roots of the function. We can see that on the x values, it goes from highest power down to lowest, so it is in standard form. We're going to start by labeling a, b, and c. A is the coefficient with the x squared, so in this case it's a 2. B is the coefficient with x, which is a 4, and c is the constant. Since it's subtracting 1, c is a -1. We're then going to plug into the equation. We have x equals, remember this is read as the opposite of b, so we're going to take the opposite of 4, which is our b value. We have a plus or minus, a large square root. Inside the square root, we're going to take the b value and square it. We're going to subtract 4 times our a, which is 2, times our c, which is -1. And that whole thing is being divided by 2 times our a value, which is also 2. There are 3 sections of this equation now. We have this value out here, so we're going to leave it as a -4. We have our discriminant, which is inside the square root, only the stuff inside. So I'm going to start by writing a square root, and then I'm going to put this 4 squared minus 4 times 2 times -1 in my calculator, and you can pause the video and try that now if you'd like. That should give us 24, so I'm going to put a 24 here. And then our third section is this denominator, so 2 times 2 is a 4. Since the discriminant ended up being a +24, we're going to be taking -4 and adding and subtracting that square root. So we're going to get 2 real number solutions, or 2 real roots. And we're going to practice putting this in our calculator. So in our calculator, we're going to first put in -4 plus the square root of 24, all divided by 4. I would pause the video and try it yourself. It's going to come out to about 0.22. You should get a long, non-terminating decimal. The second time we do this, we're going to go with -4 minus the square root of 24, because again, that's what that plus minus symbol means in the middle, that we have to do both operations, and we do so separately. If you check this one, it should be about -2.22. So because we got answers that are these really messy decimals, there's no way we could have solved the original equation using our factoring. Example 2. If you look, we have an equation this time, and we're asked to solve for x. I see that I have a power of 2, which would tell me that quadratic formula is possible because the highest power is a 2. But I noticed that not everything's on the same side of the equation. So that's what we're going to first do, is we're going to move everything to one side to get it into standard form. And it's easier to move one item than it is two. So I'm going to move this -2x that's on the left first. And we always want to cancel with our inverses. So if I have a -2x there, I know I'm going to cancel, but with a +2x. And I'm going to have to balance the equation, so I do it on both sides. -2x plus 2x is 0. I'm going to bring down the 3x squared. I'm going to put the 2x next because, again, I need it in standard form, and a positive 5. Now that it's in standard form, we can label A, B, and C. A, again, is the coefficient with the x squared. B is the coefficient with x, and C is the constant. And then we're going to substitute into our equation. So x equals the opposite of b, so the opposite of 2, plus or minus. We got a big square root. We need our b squared, so this time it's 2 squared minus 4 times our a, which is 3, times our c, which is 5, all divided by 2 times a, which is again 3. Just like last time, we're going to take each section. So I have -2. I'm going to leave it alone. We have our plus minus. We're going to write our square root. Then you're going to go ahead and put the discriminant inside your calculator. So we're going to try 2 squared minus 4 times 3 times 5. You should get a -56. And then in the denominator, we have 2 times 3, which is 6. So this time we ended up with a negative discriminant. If you tried to put that whole thing in your calculator, it's going to say domain error, because this is actually going to give us an imaginary number. If you remember from last year, it's not possible to take a square root of a negative and get a real number answer. So in this case, it has no real roots. So without even graphing this parabola or this quadratic, I know that this quadratic is not going to actually pass through the x-axis at all. We can simplify this though. We're going to take the square root of -56, and we're going to take out the negative. So the square root of -1 is defined as I to show it's an imaginary number. So we're just going to bring the negative out as I and leave the square root of 56 over 6. Now, if you put the square root of 56 in some calculators, they will simplify the radical for you, but not all do. So if they don't, you're going to simplify a square root by factoring. I know that 56 is 7 times 8, and I can break down 8 as 2 times 4, and 4 is 2 times 2. And then for square roots, we always look for pairs. So I have a pair of 2's that I can bring out. So I'm going to rewrite that as -2 plus or minus I times 2 that I brought out times the square root of, it looks like I have a 2 and a 7 left, so 7 times 2 is 14. And then if you're simplifying the radical, you want to look and see if these 3 numbers have any common factors. So it looks like 2, 2, and 6 do have a common factor of 2, so we can take out a factor of 2. And if I divide -2 by 2, I'm left with -1. If I divide 2 by 2, I'm left with 1. So just the I and the square root of 14. And then 6 divided by 2 would leave a 3. So we have 2 roots sitting here. Again, they're both imaginary, so we're not going to see them on the graph. But we have -1 plus I times the square root of 14 over 3. And we have -1 minus I times the square root of 14 over 3. For this last one, we're solving for x. Again, I see that the degree is a 2, so I know I can use quadratic formula. I also noticed that not everything's on one side, so we're going to move that -9 over. To cancel out the -9, we're going to add 9 to both sides. We will have x squared plus 6x plus 9 equals -9 plus 9 is 0, which is what we wanted. Now we can label. Here's A, our invisible 1 sitting there. We have our B, the 6, and C is 9. So we've labeled A, B, and C, or identified them. Now we can substitute into our formula. We have the x equals the opposite of B, so opposite of 6 would be -6, plus or minus. We have a big square root. B squared is going to give us 6 squared minus 4 times our A, which is 1, times C, which is 9, all divided by 2 times our a, which is again 1. We're going to go piece by piece. So we have this first one, x equals -6. We'll just leave that alone, plus or minus. We have our discriminant that we'll need to simplify. Again, this is the discriminant. That's what you should be putting in your calculator. So 6 squared minus 4 times 1 times 9. If you put that in your calculator, you should get 0. And at the bottom, our last part, we're going to do 2 times 1. So 2 times 1 is 2. This time our discriminant is 0. Well, if we were to simplify, we'll have -6 plus 0. And then on the other one, we'll have -6 minus 0. And we know that adding and subtracting 0 is not going to change anything. So we're actually going to get 1 root. So we can just get rid of that square root of 0. And we're left with -6 divided by 2, and -6 divided by 2 is -3. So we have 1 real root, which is at -3. So this parabola is going to have a bounce back. It's just going to hit at -3 on the x-axis and then bounce back. We're going to go through another practice problem, and you're going to want to follow along because you're going to be stopped to answer more questions. So we're going to solve for x. We have 2x squared minus 5x plus 1. I'm going to have you identify A, B, and C. Did you get A equals 2, B equals -5, and C equals 1? If you did, great job. Now you're going to plug into the equation. I hope you remembered the negative in front of the -5, or if you wrote it as a +5, that works too. We had a -5 squared inside the discriminant, minus 4 times 2 times 1, and in the denominator 2 times 2. Now you're going to simplify. We'll go piece by piece. So the first thing you're going to do is simplify here. And again, you might have already done that. So the opposite of -5 is a +5. I'm going to give you a little bit of time to plug in this discriminant and calculate it in your calculator. Did we get 17 for our discriminant? And then at the bottom, 2 times 2 is a 4. Going back, if you did not get 17 as your discriminant, you might want to make sure that you have parentheses around the -5, where we talked about if you ever plug in a negative, you have to have parentheses around it. Since our discriminant is a positive, how many real roots should it have? It should have 2 real roots. Anytime we have a positive discriminant, we're going to have 2 real answers. I'm going to give you some time to plug these into your calculator, and you can go ahead and round to 2 decimal places. So you're going to have 5 plus the square root of 17 divided by 4. And then you're going to try 5 minus the square root of 17 divided by 4. Again, round to 2 decimal places. And there are 2 real roots. Again, these are decimals. You wouldn't be able to do this problem with factoring. If you can factor, factoring is always faster. Quadratic formula works every time you have a quadratic. So if you're ever stuck, you can't find the factors, you could use quadratic formula. But for something like this, you would have to use quadratic formula. For our next practice problem, you're going to identify the roots of y equals -6x squared minus 2. So if you notice, it's not quite in standard form. We have a power of 2, and then we have a constant. So let's fix that. We're going to change that and make it -6x squared. We're going to fill in that missing x with a 0, and then minus 2. This will help you identify A, B, and C, which you can go ahead and do now. Okay, we have our A, B, and C. We're going to plug into the equation. I'll let you choose the correct one. Here's everything plugged in. We're going to go by section. So here we have -0. We know that 0 doesn't have a sign, so we can just actually leave that off. plus minus square root. You're going to be plugging that discriminant into your calculator. You should have got negative 48 is your discriminant. How many roots do we have? How many real number roots? We have no real roots. Lastly, the denominator, we have 2 times negative 6, so negative 12. We're going to simplify the radical. So the negative inside the square root can come out as I. And we have a square root of 48 left over and our negative 12 at the bottom. So simplifying the square root of 48, we're going to factor. I might go with 6 times 8 is 48. 6 I can break down into 2 times 3. 8 is 2 times 4. And 4 is 2 times 2. Again, we're looking for pairs because there's an index here on the square root that's invisible of a 2. I have 2 2's. And I actually have another pair of 2's, so I can bring out 2 2's. And it looks like the 3 is the only factor left over negative 12. Now if we look, I have 2 2's in the numerator, and I know 12 can divide by 4. So we're going to take out 2 2's. And we will be left with 12 divided by 4 would give us a negative 3. Or you might see that written as plus or minus I square root of 3 over 3. Because this negative in the denominator could be divided into that plus minus, it would still remain a plus minus because the positive would change to negative, the negative would change to positive. So I would probably expect it to be written like that if I was looking for the answer. Okay, for the summary, what we're going to look at to determine the number of real roots for a quadratic, that's going to be the discriminant. This is the formula for the discriminant. If it's greater than 0, meaning that it's a positive number, we're going to have 2 real number roots. If the discriminant is 0, we're going to have 1 real root. And if the discriminant is less than 0, meaning a negative, we're going to have no real roots because we're going to actually have 2 imaginary roots.